Establishing a boundary with Godot's navigation region 3D and a mob or NPC controlled with a navigation agent, we can actually define an area where mobs can wander around with minimal effort. So let's take a look at how to do that. If you've been following along, I've been building on the same project over the last couple of videos, so please go grab that and make sure you watch through the last video so that you're all caught up. For this demo, I added a second map scene, which is basically just a copy of the first map scene because I wanted to separate those things out. And in order to get that to spawn correctly, you also have to add it to this map spawner object, which you can see here. So once that map loads on the server, it'll successfully spawn and sync throughout all the clients. So that's the basic setup you'll need to get started on this demo. So I'll just go ahead and close that game scene and we don't need to see the scenes anymore. So on our map 2 object, you can see that I basically just copied in everything from the map 1 node and pasted it here. Before we go any further, I just want to let you know that Godot has some pretty extensive docs on this navigation topic. As you can see here, it tells you exactly what you need to just get up and running. And I'm basically going to be following this instructions here under the setup for 3D scene. So the first thing you'll notice is that we need to add a navigation region and a navigation mesh to that navigation region 3D. So let's look at how to do that. So we'll come over here and add a placeholder node for the navigation regions. And then we'll go ahead and create a navigation region. So select your newly created navigation region and hit new navigation mesh. And then come down and create a child node, which is a mesh 3D instance in this case. And we're just gonna create a plain mesh. And I have a pretty good idea of the size, so I'm gonna go ahead and just enter that in. You can make this whatever size you want for your game. And I also wanna give it a color so that it's easy to spot. And if you take a look at the 3D scene, you'll already notice that you can see a mesh that appears right in the middle of the map. And I'm just gonna move it over a little bit just to give it some more character. And it's basically competing with the existing mesh there. So I'm just gonna bump it up above that existing ground there so it's not competing with it. Just a hint above it. There we go. Just to make it easy to see. So once you have your mesh created, you also have to come back over, select the navigation region, and then hit Bake Navigation Mesh. And now you should have your navigation region ready to go. And I want to quickly note that if you check in the docs, there's a section called Optimizing Navigation Performance. And I definitely recommend when you're getting started to read through all of these points. It's pretty quick read, it's not very long. But if you dig through these sections, you'll notice that they point out that you shouldn't make your navigation meshes very complex. So keep it simple with whatever you're doing. Okay, so if we go back to the instructions, you can see here we've added that 3D mesh and we went ahead and selected that Bake Nav Mesh. So we do have that transparent layer. As you can see here, there's that extra layer kind of floating about. I don't know if you can see that, but let's see, there's this like extra layer floating right here between the actual mesh and the top of the navigation region that's displayed here. So that pretty much wraps up the navigation region setup. So the next thing we need to do is finish out the script that we have to make sure that our mobs will spawn within this mesh. Now, this is all dependent on your game's requirements. Just to make things simple, I'm gonna make sure that my enemies or my mobs or NPCs are gonna spawn within this region. So let's head over to the scripts. And down here we have the spawn mobs method that we developed in the last video. And we're just gonna edit this a little bit to make that work. So basically all I'm doing here is grabbing a reference to the region of this mesh so that we can get the defined boundaries of it to make sure our mobs spawn within it. So I'm gonna make a helper function that we pass in this region to that just spits out a random X and Y location in that 2D plane. So up here where I grab the mob region, that region defined here, I take the size of each side and pass it into this helper function. And we take that size and divide it by 2. That way we can create a lower and upper bound, as you can see here, and just get a random flow in between those two areas. So this is just making sure we return a vector 2D within that bounding mesh. So we can remove this as we're gonna use our new helper function. And we're gonna use that function to get a starting position where our mob is gonna spawn. And then we're gonna also calculate the first target position we want him to walk to. So let's take a look. Okay, so we've got our random start position where he's gonna spawn in the world. And then we have the first target that he's gonna go towards, that he's gonna just start pathing to. and we define those here in this vector 3D. So we get the vector 2D and then we convert it to a vector 3D, and then we set those positions respectively. And we also just updated the name variable to conform to the new variables we have here. So I think we've got everything set up to get our mob to spawn within this 3D mesh boundary here by grabbing the mesh, getting the size of the mesh, and passing those size and the region itself to this helper function. And that helper function just spits out a random coordinate within that mesh. And we just do that twice to get the start and end point where our mob is going to spawn and initially target respectively. Okay, so now that we have that set up, we can actually go and start digging into the mob. So let's go over to the mob scene. And the first thing we need to do is add a navigation agent. Navigation agent 3D, there we go. And if we go back to the instructions, we're just following along right about step 8 here. And if you scroll down a little bit, they do give you a stubbed out basic character body 3D example. And I did heavily follow this, but it's a little incomplete. So I'm gonna show you what we need to get this thing working. So we don't really need to set up anything in the node. We can basically just attach it here and then move on, at least for this demo. And the first thing I'm gonna do is update our mob walk speed. And then let's also give them a run speed, because we're gonna use that in subsequent demos. So now let's go ahead and grab a reference to our navigation agent. And we also want to add the field that the map is referencing. So we need that initial target position. And I also know we're going to need another variable called last mob position, or last mob target. And I'll talk more on that in a second. And if we look over at the documentation, the example that they have here wants you to call this call deferred actor setup function. And that's basically just allowing it to not do this. You're just basically making sure you don't call this in the ready function. So it's allowing it to process on the next physics frame. And we do that by hitting this await get tree physics frame. And then at that point, you can go ahead and establish the first target for the player or mob. Well, that doesn't really work. And there's actually an open issue for this. And I commented on there that says this isn't actually working as expected. But somebody else had pointed out that you can use or you can listen to the map events. So I went ahead and set it up that way. So let's take a look at what we need to set that up. Basically, what this is doing is the underlying navigation server isn't quite ready once this object or once this node loads. So you need to kind of give it a physics frame to go ahead and load and start up and sync with the server so that everything is working. The first thing we'll do here is disable physics processing. And we disable physics processing because eventually what we'll see is that our physics loop, our physics process loop will actually want to try to get the location, and we don't want it to try to navigate the player until this navigation server has been established and synchronized. So let's first disable the physics process. And then we'll go ahead and make that actor setup function. So what I'm doing in this actor setup is I'm creating a signal or a callback once the map has changed, and I'm going to call it map ready. And that way, once the underlying navigation server has been synchronized, we can go ahead and turn the physics processing back on. And since this is only used in our initial ready function, we can just go ahead and disconnect that callback. And then right after this, we can also set our initial movement target for the mob. And we'll use that init target position that we set over in the map script. And we're able to still do this here because the physics process has been disabled. So we can actually set that and not worry about it so that once that physics process comes up, it'll be ready for it to go and ready to process. So we need to actually create that set movement target function. Okay, so what we're doing here is the set movement target is basically a utility function that anytime we want to update the location that we want this mob to head towards, we pass in that next target. And I did a little check here so that we don't just keep spamming this. And in the case that you do call this function repeatedly, we don't actually use the pass in target unless it's been changed. So if it has changed, we go ahead and use the navigation agent set target position and pass in that new target. And then I just capture the last mob target so that we can make that next comparison the next time it's called. Now, this is really important because this isn't really covered in the documentation, but this is really the bread and butter which makes that mob move, at least as far as I can tell that I've been able to figure out. So what will happen is you're going to have some secondary script like an AI script or a movement script that sits in parallel with your mob that tells the mob where to move every so often. And we'll get to that in a second, but basically you're going to be calling this function, which in turn calls this function, which lets the mob know where his next endpoint is going to be. So the next thing we can do is look down at the physics process function. And this is set up pretty well, but the only adjustment I want to make that I caught between now and the last video is it seemed like in host mode, the animations weren't working. So I think what we need to do is detect that we're in host mode and make sure those animations get applied. And I have a slight refactor to the animation function, so we'll check that out in a second. So for this apply movement function, this is basically anytime you want to move the mob. The way that it's set up now doesn't really work with our navigation agent and region setup. This was for the previous demonstration where he can just chase you whether or not he had a player target. Well, we're going to basically split it up into two functions: pursue target and wander movement. For this demo, we're just going to look at the wander movement setup. The pursue target we'll look at a later demo. So we can basically just take what's in here and copy paste that into the pursue target for now. Okay, so we don't really need to look at this function because we're not really going to use that in this demo, but I just wanted to have it established so that when we do come back to it in a subsequent video, we have a good starting point. So if he doesn't have a target player, he's just going to be wandering around the region. So let's set that up. So if you're wondering what this is, if you read through the docs, it's basically saying that once the navigation agent has reached his end goal, his current target position, you don't need to keep querying for it. So you don't want to keep spamming this. It's a pretty heavy load on the game's process. So when he's reached an endpoint, go ahead and call this is navigation finished. So each time the physics loop executes, you call this is navigation finished. And if it is, you go ahead and return because you don't need to keep moving him. However, I've kind of built upon this that says once he's reached his endpoint, we're going to go ahead and ask our AI script for the next endpoint. So he'll basically walk from A to B and then he's finished and then he asks for another endpoint and then he gets another one and then he can continue to walk. You don't have to set it up this way. You can just tell your mob wherever he should move at all times, but this is just an easy way to get it going. So what we've done here is we've halted his velocity because he's finished navigating, and we set his animation back to idle. And then what we do is we ask this mob AI movement script to get the next target that he should move to. Now we don't have that set up yet, so we're going to come back to that. But basically what it'll do is it'll grab that next target and go ahead and reestablish this next movement position with that set movement target. Remember that function we talked about a minute ago and how important that was? That hits this. So he's basically only getting told where to go once every time he needs it. And if you read through the optimization or the best practices, you're not supposed to just keep spamming go here, go here, go here. Like, you do not want to spam this function. It's unnecessary and it's overkill. And as a side note, if you do have a bunch of mobs, you don't want to be hitting this set target position for all the mobs that you have on your screen at the same time. So figure out a way to stagger those. And I have an idea of how to do it for my setup, but maybe we can get into that more at a later video. Let me know in the comments if you're interested in some strategies for that. So if we go back to our function, that is just when he's finished the route. So if he hasn't finished the route, like if he's continuing to navigate towards his end position, well, let's build out what that looks like. So what we've done here is we've added these two lines of code here that will say, get us the next path position. And remember, we set that path position just a second ago that we talked about up here. And where did it go? In this set movement target, we've set the position of where he's supposed to move next right here. And down in this wander function, you basically get that next position that he's supposed to currently move. So he's not there yet, but he needs to get there. So this agent is basically allowing you to get the next position in line where he needs to keep heading towards. So it's just moving him to that direction. So that's the next position on this path. So we take that and we do a direction to, and we set a new velocity to that position that he's heading. So that's our velocity that we get that we need to apply to this mob. And then I also just make sure he's grounded on the floor so he's not floating around in space. So I added this call to onVelocity computed. And so after we have our new velocity, we make a call to that to make sure that we have the velocity set. Now, so if we look under the navigation agent docs, there's a section for the character body 3D setup. And if you look there, there's this function that they created called onVelocity computed. And it's just a helper method to set up a safe velocity that your underlying navigation agent has in the server has calculated for you. Now, you probably don't have to have this in a second separate function, but once you get into a more advanced setup and you're using avoidance, you're gonna have to wire up this signal so that those avoidance logics can call back to this and give you that correct velocity. So it's a good idea to put it in a separate function. So let's go ahead and create that function. And we'll go ahead and set the velocity of this mob to the safe velocity that has been calculated. And again, that was calculated up here by these two lines and then passed in to this function call here. And the last thing we need to do is just make sure that he's looking in the direction that he's heading and establish that he's using the correct animation. Okay, so we take his global transform and add the velocity to it. And I also just cap the Y at 0 so he's not leaning over. And we basically look at that direction that he's handling or that direction that he's heading with that transform. And I also just set the current animation to walk if he's actually moving. And if he's not moving or if he's in an idle state, we just apply the idle animation. Down here, I just want to do a quick refactor. We don't really need to pass in the animation here. So let's just tweak this really quick. And we can get rid of this. Great. And I think we're using animation at top. Yeah, so up here, we don't need to actually pass in the current animation. We're just gonna go ahead and remove that, but we do wanna make sure that we make a call to animate so that whatever the current animation is set to, like idle or walk or whatever, we wanna make sure that that's established early on in those physics process. So like for example, when the game loads, it's gonna default to the idle animation, as you can see here. And if you haven't already picked up on this, and if you're having issues getting that initial animation showing up, or he's in that T-pose bug, there was a bug in some of the code that I had put out there. Just go over to this animation tree on the mob and select this initial transition, and over under the advanced section, just make sure to remove anything out of this conditional because you want it to start and then immediately go to that idle animation. So that's how to fix that issue if you are having it. If not, well, then you can ignore it. So as long as your current animation is set to idle, he will load with that idle animation and the mob will be good to go. So I think we have everything established for the mob. So next we need to do is add a script for his movement. So if we come over under the mob, let's add a new node, just a regular node, and let's just call it mob AI movement. Okay, and then we'll go ahead and create a script with the same name. And let's make sure we put that in the correct location. Great. So we don't need this. Basically don't need anything in here. This basic AI script just spits out a random vector. Now you can probably build this out to be a bit more complex, but for this demo, it gets the job done. So what basically happens is once the mob gets to his endpoint in that path, he asks this script, hey, give me my next point. And then this script just returns a random vector. And then he'll just continue to walk in the direction of that random vector until he gets to the end. And then he asks it again and so on and so forth. So let's build it out. Okay, so the mob will make a call anytime he gets to the end of his path. He makes a call here and he passes in his current position. And then we just pick a random vector between -10 and 10 for the X and Z axis, which is just that 2D plane that he's walking within. And then we just apply it to his current position, and then he'll just walk to that position. And we just keep calling that. Now, this is probably the most basic AI movement script that you can develop, but it's a good starting point to get a feel for how this works. So I'm sure for your game, or if you want something more complex, you're gonna have to build out this portion of it. So let's see how to use it. So you remember back when we did the wander movement setup, we made a call to the mob AI movement. Well, that's exactly what this is doing right here. And we make a call over to that script and we pass in the global position of the mob, and then he will get a position back. And I just like to print it out so that we can see how often that next position is being called. And therefore, while you're in development, if you notice it's being called like crazy, that's a red flag. You don't want to spam this function. So you don't want to spam this set movement target. So if you see this printing out a lot, then you know you have an issue because you're calling the movement position way too much. Oh, I have some additional cleanup I just need to set here. And again, this is under the pursue target, which we're not using for this demo. Okay, so I think we've got everything set up for initial demo. Let's see if it works. Oh, we already got a bug. Looks like our initial target is not being set. So I quickly realized that we were trying to load the map from the last demo. So we need to load map 2. So let's go ahead and update this to map 2. And that's over in the gameplay utility autoloader. So now that we have that, we can close that and let's see if it works. Okay, great. So I loaded in and all the mobs are there, but they're not really doing anything. So they're just kind of hanging out, and you can tell that they loaded correctly. They're all within this mesh. All 10 of them are within this mesh. So we've got that working. So let's take a look at the debug. Maybe there's some more information there. Oh, looks like I have an issue with the map change call. Okay, so the map ready actually accepts the RID or the ID of the map server that's being ran. So just make sure that you add in a parameter there. So that's a quick correction. And I think that should be good. Now let's try to run it again. Okay, and if we turn around, okay, great. All the mobs are just randomly running around. I think they're actually chasing me, which is funny because I didn't think that pursue logic would work with this setup, but it looks like it is working. So because I have the area of activation for our mobs set to really high, they're gonna constantly be chasing us. So let's actually try for this demo to lower that. So I think the radius is 20. Let's just make it, I don't know, 2.5. That way they're not gonna really, we just wanna play around with the wander logic. We don't wanna see them pursue us for this demo. So if I drop back in, now the mobs are just randomly walking around this area, and you can see that down in the console there, get next movement is happening every few seconds. So they're basically just picking a new point and heading towards it. So if we just watch this for a second, yeah, the animation is a little off for their movement speed as it seems like they're sliding around a little bit, but for the most part, it's actually working and they're not leaving this boundary. So if a vector establishes an endpoint outside of the navigation region, the path endpoint will prevent it from going outside of the region. And one way to check that out is, let's go ahead and turn on debugging. So go over to your mob's navigation agent, hit debug, and then hit enable. And then we'll actually be able to see the target endpoints. Okay, so you can see here, this guys that are coming towards me. So as soon as they get to those endpoints, they ask the AI to get a new one. They ask again and ask again. And you can see that it's just no longer, it's just not going outside of that region. So that's working as expected. It's not as random as you might want, but again, this is a really rudimentary AI setup, but it does get the job done if you just want to play around with it and learn how to use it. And you can see there's a couple mobs stuck on this middle pillar here, and because they're not very smart, so that's where a more complex AI will have to be written so that if they get stuck in an area for more than a few seconds, go ahead and just pick or request for a new endpoint target. Yeah, and all this movement is, again, just to review really quick, the whole like bread and butter of this process is this set movement target here with this nav agent set target position. You don't want to spam this. If you read through the documentation, I definitely recommend reading. You don't want to spam this, and you also don't want to run this every frame. Like, you should not be calling this every physics frame. This should only be called as needed. So whatever AI or script that you use to give the mob the next position, do that not as often. Don't do that every frame. Do it not so often. And another thing is they don't want you to run the set target position at the same time for more than just a couple mobs. So like if all 10 mobs were calling that set target position over and over and over at the same time, that's a little too much load for the underlying navigation server. They don't want you to do that. That's going to introduce some lag and some processing overhead that you don't really want. And one way that this simple algorithm is preventing that is it's getting different vector lengths for the mobs to walk towards. So every so often it'll select a new one, but that frequency isn't the same for each mob, right? So one vector might only be 5 meters, another one might be 15. And if you look over at my AI script, I'm basing it between -10 and 10. So you can basically get a vector between -10 and 10 in that 2D plane. And that can go up to 20 meters, right? So you might have one mob who's only getting 2 meters and one that's getting 20 and anywhere in between. So because he's not going to request it right away due to his movement speed, that's going to vary per mob. You're not going to request that you're not going to request that set target position at the same time. So I've kind of baked in a little buffer zone for it automatically or just by default. So let's see if I can get them unstuck by pursuing me for a second. So after they pursue me and I leave their area activation, they go right back to their wander script. So if you look back at our applied movement, which calls pursue target or wander target, once I leave the area activation, the target player will be null. So he'll no longer chase me anymore and he'll go back to calling this wander movement. And once that wander movement kicks back in, if he's not finished, he'll finish his path, which is probably immediately because the target changed, and he'll go ahead and request that next movement target. And then of course, subsequently calling that next movement target called to set target position. So that's basically what's happening. And they're all getting stuck on that middle pillar there. It's kind of funny. And they'll chase me for a second and then they'll all pick a new location. See, if when I walk away, they'll just, maybe they're picking up on the same. Again, I wasn't really going to cover the pursue functionality for this demo. So we're going to look at that again, but it looks like they go right back to the old wander location, which is happening there. So if we remove that pillar just to make it a little cleaner, let's see, we just take this pillar and get it out of the way. Yeah, so they basically start out with some initial endpoint, and then once they get to the end of that endpoint, they pick a new one. They ask the AI for a new one. So if you watch this guy come to the end, he picks a new one, and then you can basically just follow him along for a little bit just to see what it looks like. And if that vector goes outside of the bounds of this mesh, it caps him. It won't let him go outside. That movement endpoint will actually stop and recalibrate to be inside the mesh. Yeah, this looks like it's working well. So we've got a basic, AI mob wandering setup here. We've defined a navigation region 3D with this, as you can see with this green mesh. I just made it green for debugging purposes. And we've got a navigation agent here on all the mobs that basically just pick a random target, a random vector, and wherever it goes, it just allows them to walk wherever the vector points, and it keeps them bounded within this navigation region 3D. So I'm probably going to do a couple more videos on this topic. Like I want to cover navigation links and maybe obstacles and avoidance and setting up the pursuit of the target player and how that would work with this and how that pursuit transitions back to a wandering here, like you can see on the screen here. I want to look at how to set those things up, and I don't know if I'll do it in one video or a couple, but if you're interested in seeing something specific that you'd like me to cover, please let me know in the comments and I'll definitely try to include that. So if you enjoyed this today, please give it a like. I've got a lot more on the way, so make sure you're subscribed. Thanks for watching.